Welcome to this lecture. So far over the last few lectures, we had seen that requirement specification is a very important task during software development. We had looked at how requirements gathering, analysis and specification can be done. We looked at the standard specification template, that is IEEE 830. In this lecture, we will look at a few other aspects of the requirement specification before we conclude this topic. Let us look at some of the desirable properties of requirement specification document and what should not be there, how to write it and how not to write it. Let us proceed with that objective. Let us look at some examples of bad SRS document. The worst form of document possibly is just a essay. It is unstructured specification, just a description of what is required. This is one of the worst types of specification, because it has a lot of problems. Typically, if you want the customer to write about their requirements, they would write in the form of a narrative essay. Here various types of functional, non-functional requirements, constraints are all mixed up. Let us look at what would be the problems if somebody just uses this kind of a document, a narrative essay, as a specification document. One of the most difficult problems that will be faced is that it is difficult to change, because various issues, the functional requirement, non-functional requirements, constraints, etc., are all mixed up. Let us say we want to change a functionality during the development or maybe after development. It would become very difficult, because this functionality would not be described just at one place. It would be all mixed up over various pages, and to find out where all to change, maybe we can change few, maybe we can due to oversight leave some of those. So, changing it is a very tedious task, and unless you are careful, the changes will not be proper. It is difficult to be precise, because it is all mixed up, just a narrative essay, and we write the issues as it occurs to the mind, and therefore, we need to refer to various places. Previously, we had described that this does this, and here we describe, later we will describe this, etc. So, it is all interspersed and it becomes very descriptive. It is difficult to become unambiguous when there is a large set of sentences all mixed up. It can happen that if we read some sentences in isolation for some functionality, it can give a ambiguous meaning. There is scope for contradiction, because as we write a large document, forget what was written earlier, and it is easy to contradict. If such problems exist in a document, then it becomes very difficult for the developers, for the testers to carry out their task. And also, please remember that requirements change a great deal during development and after development. During the development, on the average about 40% of the requirements are expected to change, and even after the development the requirements continue to change. If it is a unstructured specification, it becomes very cumbersome, consumes large effort cost to change the document, and yet there will be several mistakes and problems. And that is one of the reason that hardly there is any commercial organization who would write their requirement specification as a narrative essay. Another very undesirable aspect of a bad SRS document is noise. Noise is something which is unrelated to the problem. Basically, when the document is written in a very verbose style, there is a tendency to put information which is not really part of the problem being solved, and this makes it difficult for the developers and testers to figure out that which sentences to ignore and which sentences to take. Another very undesirable aspect of a requirement document is silence, which is basically omitting some important issues, maybe functional requirement, non-functional requirements, constraints, interfaces, and so on. Over specification is another very undesirable characteristic. By over specification, we mean addressing how to aspects. For example, let us say we say how to store the library member names, that they should be stored in a sorted order, sorted descending order in a file, etc. And then once we write it in the SRS document, it becomes binding, and the designers have very little flexibility. If we have already mentioned here should be stored in a sorted descending order in a file, then they cannot use a database management system, and also they have to keep it in a descending order, even if for some other task they may need it in ascending order. So, the how to aspect should be carefully avoided while writing the SRS document. Another problem with the bad SRS document is contradictions. Specifically, this kind of problem occur in narrative essay type specification, where contradictions between various parts of the document exist, and this is to be consciously avoided. Ambiguity: if there is anything mentioned in the document which cannot be quantified, becomes very difficult to test. For example, if we write in the document that it should have a good user interface, then the tester, the developers will all be in confusion what is meant by good user interface. How does somebody test and say that it is a good user interface? Another problem with the SRS document is forward reference. As read the document, we only know what has been already written, and if we write in the document that refer to a later section, then somebody would have to turn pages, read that, and again come back, and if that happens many times, it becomes really difficult for somebody to read it. One more problem is wishful thinking. If the person writing the specification document is not careful, he might agree to some functional requirements which cannot be implemented. Realistic solutions to these cannot be obtained. and therefore, it is important that the analyst or the person who is writing the document should have an idea that how to solve the functionality that is required or a non-functional requirement. Commitment to unrealistic requirements becomes very difficult, and later would have to again change the requirement after the developers have tried implementing them. Let us just discuss a few suggestions on how to write good quality requirement document. One thing about the requirement document is that there are many stakeholders who would like to read the document for various purposes, and therefore, readability of the document is an important concern. For anybody to read the document, the sentences should be short, the paragraphs should be short. A sentence which is 20 lines long would become very difficult to read. The sentences should be simple and typically one line and so on. Similarly, the paragraphs should be small paragraphs. Active voice, use of active voice, use of proper grammar, spelling and punctuation. The terms should be consistently used and should be defined in a glossary, so that somebody who does not understand a term as reading through the document can refer to the glossary. And also, before completing writing the document, the reviewer, the developer of the document, the analyst and also the reviewers should read it from the perspective of the user and also from the perspective of the developer. From the perspective of the user, understandability, readability is very important, and from the perspective of the developer, sufficient details should be there, and from the perspective of the tester, it should be able to write test cases. It should be possible to write test cases to test the requirement. Sometimes the requirements are complex, but in those cases it is important to split the requirement into sub requirements. One of the major reason for doing that is that traceability. Since it is a complex large requirement, its implementation will require many design elements, many modules or functions in the code, but if we have split it into sub requirements, then each sub requirement can be traced into a few design elements and a few functions modules in the code. Also, it becomes easier for the tester to write test cases, because for every sub requirement the tester can write test cases. Otherwise, if it is a huge complex requirement, the tester may overlook some of the aspects to test. In the requirement specification process, we said that after the requirements document is written, the specification is done. That is, first is requirement gathering, analysis of the requirements in an iterative manner, and then finally trying to write the specification document using a standard template. Again, we might have to do some gathering and analysis, but after the requirement document is completely written, it is submitted for review. Review team typically consists of the customer, the developer, tester, basically all stakeholders. the customers check whether the requirements conform to their actual requirements. The developers see if any details are missing, the testers see if every requirement can be tested meaningfully, and the defects that are detected by the reviewers can be corrected. Typically, the review is done by developing a checklist, and it is checked that every element in the checklist is satisfied by the SRS document. Let us look at if the processing logic is complex, how do we meaningfully represent it? The processing logic is in terms of if certain conditions are satisfied, then do something and check for further conditions and so on. If this processing logic is very complex, just a text description becomes very difficult to understand, and for the developers to be able to meaningfully develop solutions to that, and also for the testers to write test cases. And also in a text form, if we write a very complex processing logic, it is likely that some of the conditions can be overlooked, and that is the reason why some semi formal techniques are used for representing complex processing logic. Two techniques are very popular: decision trees and decision tables. Both the techniques are not specific to this domain, they are used across various other disciplines. But then let us see how it can be used to represent complex processing logic. These are very simple concepts. In a decision tree, as an example is given here, along the edge each decision is represented. So, a junction here represents some decision to be checked, and depending on the decision some actions are taken, and this gives it a tree like appearance, that every node of the tree some check is made on conditions, and depending on which condition is satisfied, that specific branch is taken. And the leaf nodes here on the tree, this can be a multi-level tree, and each node of the leaf node of the tree write the actions to be taken. So, if it satisfies certain conditions on the path, then these actions will be taken. One of the advantages of the decision tree is that it gives a graphic view of the logic that is involved and the actions that will be taken if certain logic conditions hold, and we can easily detect if certain conditions are missed. Let us take an example. It is a very simple concept. I am sure that everybody would be able to draw this kind of diagram, but just to illustrate how to draw, let us take a simple problem. Let us say we are trying to develop a library membership automation software, and as the user selects create member, there are three options which come up: new member, membership renewal, and cancel membership. So, let me first describe the problem and then we will see how to do the solution. So, the problem is that this is a requirement in create member, and as the create member option is chosen, there are three sub options which are displayed: create new member, membership renewal, and cancel membership. If the new member is selected, then it just asks the some details about the member like name, address, phone number, etc., and then creates a record and then prints the bill. So, during in the menu, if we select the new member, the actions taken is get the details of the member, create the record and print the bill. So, that is what it says, that once the details are obtained, a membership record is created and the bill is printed for the membership charge. If the renewal option is chosen, then the name represents a valid member, then the expiry date is updated and the bill for the renewal is printed. Similarly, if the cancel membership option is chosen, then the details like name etcetera are obtained and the balance amount is printed in the on a check and then the membership is deleted. If any other option is chosen, then there is a print error message. So, this is the representation of this simple, this is not a very complex processing logic, but then just to illustrate how to write the decision tree, just explained with respect to a simple example, but then for complex processing logic there can be many decisions at each level and this will become a multi-layer tree. Another alternative is the decision table. The decision table represents an alternative way, the same thing. Here we represent which variables are to be tested to determine which condition is satisfied and then what actions to be taken if the conditions are true and the order of the decision making. So, it is a table, as the name says, the decision table is a table and the first few rows, these actually define the conditions and here each variable here v 1, v 2 etcetera, what are the values for that? Sorry. So, v 1, v 1, v 2, v 1, v 2 etcetera, and this set of combinations of the variable values v 1, v 2 etcetera, these define a condition and the lower part of the table, these define the actions. So, actions can be a 1, a 2, a 3 etcetera. So, if this set of conditions are satisfied, that is some variable has some specific values, then maybe we will say that action a 1 will be taken, and if the conditions have some other set of values, then the let us say action a 3 will be taken. So, here if you notice that the upper part of the table, this represents the conditions. Conditions are specified in terms of certain variables having certain values. So, v 1, v 2, v 3 etcetera, these are some variables and whether they have some values, it can be Boolean variables which can be let us say on, off etcetera. These can be integer variables also, and the lower part of the table represents the actions. If the variables have certain values, then the corresponding action is taken, and each of these columns here is called as a rule. So, this is a tabular representation, unlike the tree like representation in a decision tree. Typically, this becomes very compact representation. The trees tend to become large for very complex processing logic, but here it is a compact representation. In the upper rows of the table, what are the variables or conditions and what will be their values are mentioned, and typically all possible combinations of the conditions and values should be written. So, for example, if a condition V 1 or let me just say C 1 and C 2 are two conditions, then we have to check for C 1 is let us say true on and off, or C 1 is let me write true and C 2 is let us say false. Similarly, C 1 is false, C 2 is true. C 1 is true, C 2 is true, and C 1 is false, C 2 is false. All possible combinations of the conditions should be written, and this forms the rule. And what is the action to be taken if this is true and this is false? Those are specified here, and each of these becomes a rule. These are Boolean conditions, but then if there is a variable, then we have to consider all possible combinations of the variables. You can try representing this in a decision tree. One of the difficulty in a decision tree is that it becomes difficult to check whether all possible combinations of conditions have been taken care or not, and also the trees are not very compact. Whatever we represent in the form of a slightly larger table, a tree may spill over couple of pages, and also the table we will see later that it becomes very easy to design test cases for each rule. We write each rule here becomes one test case. Each column of the table is called as a rule, and each rule implies that if certain conditions are true, then execute the corresponding action. And for the same library system, this is the decision table representation. So, if it is the conditions are whether it is a valid selection, new member, it is a renewal or a cancellation. If it is it is not a valid selection, then it is immaterial, it do not care for all these three, and then the specific action to be taken is to print a error message, display an error message. Okay, not completed the lower part, should have written here display error message. If it is a valid selection and then it is a new member, then we should print, ask for the member's name, build customer record, generate bill. Similarly, for if it is a valid selection and it is a renewal, then you have to update the expiry date, print check. Okay, sorry, not print check. And then update the expiry date and then display message. Similarly, for if it is a cancellation, then update delete record and print check. As you can see that decision table, decision tree are very simple representation of complex processing logic. It has the advantage that if anything missed during specification can be easily checked here. It is easier to understand a decision tree or a decision table, and also it helps the developers and the testers. Now, we are running out of time. We will stop here and continue in the next lecture. Thank you.